moving ahead in our unit to PO20. Before we get to this, though, let me just give a reminder to each of you about what is due and when this last week of the trimester. All math packets are due tomorrow. I did get some math packets turned in for me to check over the weekend, so I'll get that back. I think, Anthony, you were the only one from this class that turned in, so I'll get that back out. When you turn in your packet, please make sure your name is on it. Be responsible and check. I'm not going to have the opportunity to look for no names, bring them in, have you look through the pile. And so if you turn it in without a name, you're essentially turning in a 0, right? Please make sure your name is on it. Packets 1 through 4 are due tomorrow. Retakes, however, can be done through Thursday. I'm after school today. I'll be after school on Wednesday, which is a change from the normal Thursday. This week it's Wednesday after school, as well as today. And then Thursday in class will be a retake day. Zoe, when am I here after school this week?
Today and Wednesday.
And when is it a retake day? Class? Good job. Okay. So today and Wednesday after school, Thursday in class. Any retake that you do this week will count. Math packets must be turned in tomorrow. Okay. Onward and forward to PO20. So we've been talking about slope. In PO19, we first introduced it, and we learned that slopes and linear functions, like I said, go hand in hand. Okay. Without slope, it is not a linear function. And a function is not linear unless it has a slope. So we define slope a number of different ways. Girls, quiet. In CO19, remind me, what is one way that we define slope in CO19? Nolan.
Rise over run.
Rise over run. We have that phrase here. Good.
Vertical change over horizontal change.
Okay, vertical change. I'm going to put change in y over change in x. Change in y over the change in x, okay? Which is essentially, like you said, that vertical change over the horizontal change. But what slope actually does, slope describes how a line moves across the coordinate plane. It tells us information about the direction, not directions, slope can only go one way, direction and steepness. Okay. Change in y over change in x, it describes how a line moves across the coordinate plane, both with direction and steepness. Sir, why are you only sharpening this now? Why does it have it every class? It just breaks. We'll do it quickly while people are writing the definition.
It's not my fault.
Yeah. So we talk about direction. Girls, right. A line can move across the coordinate plane, either going up from left to right. And what type of slope causes a line to move up from left to right? By type of slope, I'm talking about the sign of it. Yes. Positive, right? When you think positive, you're thinking up. That's good. Okay. If a line is moving downward from left to right, it would have negative slope. Okay, so a slope tells us something about the direction of a line. Is it going up from left to right? If the slope's positive, that's the direction that it'll be moving. If it's negative, it's down from left to right. It also tells us how steep it is. What would the slope of a line that is very, very steep look like? Who can give me an example of a slope of a line that would be very, very steep? Nolan?
Can I come up in the board and show?
No, I want you to don't draw a line that is steep. Tell me the slope of a line that is steep.
1-1.
1-1. That's not 1-1 is the typical like staircase slope. If you were to go home and you were to measure the vertical length of your steps and the horizontal, they'd be pretty close. Like 11 inches and 12 inches, maybe even 12 and 12, they're really close to each other, that's about a slope of 1
Negative
over
2,
1.
2.
Negative 2, 2 is equivalent to 1 over 1. So it'd be the same thing, yeah?
1, 9.
1, 9 would actually be not steep.
It's just like,
Because if you think about a slope of like 1 over 9, it means that you've got a rise of 1 and a run of 9. You're going up 1 and over 9. If you were to connect those points, that's not very steep at all, right? That'd be a good slope for a ramp, okay?
9 over 1.
So 9 over 1 would be steep. In a slope of 9 over 1, you are starting and you're going up 9 and over 1. That is a steep line there, right? So how far apart your rise and your run are determines the steepness of it. If your rise is much bigger than your run, it's going to be steep. If your run is much bigger than your rise, it will not be steep. Okay? So last year we didn't really get into direction and steepness much, so this might be a little bit new, but that's what slope can tell us about a line. Girls, which one of you is going to be moving to the back row today? Shush. Okay. All right. So we're going to look at both graphs and ordered pairs to find the slope of a line here. And so looking at slope on a coordinate plane, if you remember from last year, okay, you're picking an ordered pair. Where does that line pass through a corner? And you're following a line until you find another corner. Like you wouldn't choose that one there. It's passing through a side. There's a side. There's a side. Here's a corner there, right? And then from the point on the left to the point on the right, vertical change, horizontal change, what's the slope?
2 over 3.
2 over 3, right? Up 2 over 3. And so the slope of this line would be 2/3. Okay? The next one, same kind of thing. You're picking that corner point. You've got a corner here. I've got another corner labeled for you down here. What's the vertical change or horizontal change for that one?
Negative 2 over 4.
Negative 2 over 4. Why is it negative?
Just
Because you're going down, right? And also notice the direction the line's traveling. It's going downward from left to right. Okay? So down 2 over 4 is the slope. And since slope is a fraction, what should we do with this? What does it simplify to be?
Negative 1 over 2.
Negative 1 over 2. Right? And notice, if I start with this point on the left, and instead of going down 2 and over 4, I only go down 1 and over 2, what happens? I'm back on the line again, right? Down 1 over 2. Look at that. Down 1 over 2. And there's my second point over there. So going down 1 and over 2 is the same thing as going down 2 over 4. Down 1 over 2 twice is the same thing as down 2 over 4 once. So slopes are fractions. They should be simplified, and that's the reason why. Down 2 over 4 is the same thing as down 1 over 2. Is this light bulbs flickering from last year, shining brightly? Yeah, we covered this, right? Okay.
Yep.
So then now we go down to the formula, and this is what you needed to know for the entrance exam. This formula is going to be one of the 3 most important formulas that you will learn in algebra. What is the formula to find the slope when given 2 ordered pairs?
Don't you have to label them first?
Well, you can, okay? And when you say label, what do you mean?
Sort, plot.
Put them on the coordinate plane?
Yeah.
No, that's the beauty of it. What if you don't have a coordinate plane? Right? What if your numbers are such that they're really far away from the origin? That's a big coordinate plane that you'll have to have there. What if you're not so good at drawing accurate coordinate planes? Okay? There's a formula that we can use as a workaround here.
y2 minus y1 over x2 minus x1.
That deserves a brilliant book. Good job. y2 minus y1 over x2 minus x1. Okay? And so when Nolan said label these, I mean, if you want to label your ordered pairs, what's x1 and y1? Well, it's the first x coordinate and the first y coordinate, right? It's the x value and the y value in the first ordered pair. X2 and Y2 refer to the second x and the second y. They are the x value and the y value of the second ordered pair, right? They're not powers, okay? They're lowered, and when numbers are lowered like that, it means that it's an order, first and second. So if this is our formula, y2 minus y1 over x2 minus x1, we're just going to plug in the numbers now. Our y2 value is 10. Our y1 value is 7. So 10 minus 7. Our x2 value is 5. Our x1 value is 3. 5 minus 3. Our numerator, 10 minus 7 is 3. Our denominator, 5 minus 3 is 2. And so our slope is 3 over 2. Right. No coordinate plane required, because all we're doing is we're looking for the change. What's the change from 10 to 7? That's 3. What's the change from 5 to 3? It's 2. Change in y over change in x, 3 over 2. Okay. Next one. Careful about negative signs, right? Label these x1, y1, x2, y2. y2 minus y1, negative 8 minus 4. x2 minus x1, and here's where you got to be careful, right? Because the subtraction, the formula has a subtraction sign in it, right? x2 minus x1. This subtraction sign is part of it. You also have a negative x value. So when you write this, x2 10 minus x1 negative 6. You need both symbols there, which of course we remember from last year PO8, this year PO. We didn't cover it this year, but what happens when you subtract a negative value?
It goes to the left. It goes.
It's like positive.
It becomes addition.
Yeah.
Okay, you won't always get a positive answer, but the operation becomes addition. This is the same thing as 10 plus 6. Okay, so our change in y from negative 8 to negative 4, that gives us negative 12. And then from 10 minus negative 6, that gives you 16. Watch out for that. Yeah.
If the numerator and the denominator is negative, would it be positive?
It would be, correct. Yep. So we have to simplify this. Negative 12 divided by 16 equals negative 3/4. And that is your slope. Okay. Try the last one on your own. Then we'll go over it. x1, y1, x2, y2. Numerator, be careful here, negative 5, our y, minus our x of negative 6. Negative 5 minus negative 6 is what you should have there. And then in the numerator, x2, 14, minus negative 11. 14 minus negative 11. Both of those operations change to addition. So negative 5 plus 6 is positive 1. 14 plus 11 is 25. There's a very not steep line at all. 1 over 25. How are we doing? Good? I sure hope so. Good. Your homework is the next page. It'll be due tomorrow. Any that you want to talk about as you peruse your way through the second page. You start with two coordinate planes. The first one, you pick your own ordered pairs to use. Just remember, look where it passes through a corner. Okay? I see it passes through a corner right here and right here. Those are the two ordered pairs that I would use. And the second one, I give you one ordered pair, and you can see it passes through another corner down here at the origin. So I would use those two ordered pairs there. The others are the formula, and there are much more formula questions than coordinate plane questions, because most of the time when you're finding slope, it'll be with the formula, not the coordinate plane. Any? Talk about? Nolan?
Oh, the third one.
Third one. 8, negative 10. That one? What's your question about it?
Can you just do it for us?
Sure. X1, Y1, X2, and Y2. Okay, you've got that negative, so just pay attention to it, right? 30 minus negative 10, Y2 minus Y1, over X2 minus X1, 22 minus 8. 30 minus negative 10, it changes it to addition. 30 plus 10 is 40. And 22 minus 8, standard subtraction is 14. How would that simplify to be? How would that simplify it to be? 40/14.
8/7?
Not 8/7. You got the denominator right, though. If you divide 14 by 2, you get 7. Tristan, what's 40 divided by 2?
20.
Thanks, Tristan. 20, right? So 20, won't even write it there. 20/7 would be your simplified fraction. Steep or not so steep?
Oh, Steve. Kind of.
Kinda. What does that roughly simplify to be? It doesn't actually, but roughly. What's it close to? If that 20 were a 21, what would that simplify down to be?
3/1.
3/1, right? It's not quite, but it's almost 3/1. If that 20 was a 21, then it would be perfectly 3/1. So it's about approximately up 3/1. That's fairly steep, okay? But that's the gist of this, right? Down below that, you've got some brain buster questions to where you need to, I give you the slope, you write two ordered pairs that would result in that slope. So you're looking for two y values with a difference of 2, two x values with a difference of 3. Okay, that's what's going on there. And then some review questions at the bottom as well. Questions, comments, concerns, complaints, compliments, congratulations, criticisms on PO20. Tis a PO, which means that you do need to pass it on your test. We're nearing the end of the unit. I think 24 is the last objective in the unit, if I'm not mistaken. So we're getting there. Test probably, reach a date next week or the week after. Late next week or early the week after that. All right.
Wait, the whole thing?
Yes, PO20. So yes, thank you. So your Unit 2 test, it's a Try 2 grade. And so my priority with grading and everything has been all Try 1 stuff. So you haven't gotten them back yet. I'm kind of saving it for when we're in Try 2 so you know what to focus on. I don't want you to focus on that when you've got Try 1 things to work on. So that's why I've not received them back yet. Grades are updated with all math packets, though, so check, see what you're missing. I have some no-name piles over on my desk. You can take a look. Anthony, I'll get your packet back to you today. You still have to turn it back in tomorrow, so don't forget that. I'll talk to you after the recording. That's right. All right, that's all I have. Oh, thanks for that.